Hello, welcome to Maths class. My name is Olujimi Gabriel. This morning we'll be talking about solids. Solid. The last time we met, we talked about area. Area is a two-dimensional phenomenon. Now, before we continue, here are the objectives of this topic. At the end of this topic, you will be able to identify, name common three-dimensional shapes such as cuboid, cubes, cylinder, prism, cones, pyramid, and sphere. 2. Identify, count, and name the faces, vertices of a solid shape. And you should also be able to draw the skeletal view of solid. Make net of solid, that is, you should be able to open up a solid shape into a flat form. Now, three-dimensional shapes. Most solid or three-dimensional shapes such as stones and tree have a regular shape. You can imagine a tree. This is a tree or stone. You can see the shape is not regular. That is, they are not equal. This is a tree. You have some branches here. You can see it's a solid shape, but it's not regular. When we say three dimension, it means it has length, breadth, and thickness or height. Now, these two occur in nature, but the ones that are man-made, like tin cans, houses, like matchbox, we call them regular shape. They are also three-dimensional figures, but they have regular shape. You can see that in your matchbox or your house. They have regular shapes. Now, example of three-dimensional figures, we have a cube, a cone. This is a cone. Then a sphere, like ball, like your ball, orange, like that. This cone, I believe you know this diagram quite well. Now, this is a cube. I believe you also know this diagram also very well. Now, this is a pyramid. You must have come across this in some of your science textbooks. Now, we have a cylinder, just like the drum in your house, the one used to fetch water. Then we have matchbox, like what you used to strike to bring out fire for cooking at home. These are also examples of three-dimensional figure. You know, we call them such because they have area and thickness. You can see this is one area. On the other side, we have another area. The distance between this face and this face is what we call thickness. Now, look at this is area. Then we call this one height or h. Just like you have in your house, those three joints, you can see you have in your ceiling. We call them three-dimensional shape. This is one dimension, two dimension, three dimension. Now, let's talk about cuboids. You know that match tray you have, when you bring it out, it's just like this, right? By the time you use blade, razor blade to cut along this line, all these edges, by the time you open it out, open out, open out, open out, you have something like this. Now, this is how this tray was formed out. When you open out, it will open up into a flat face like this. Like this. This way. This way. This is what you will have. Don't remember my diagram. I know it's not to scale. Now, look at it here. What we have here is what we have here. But you can have it in different form. Now, look at, this is a cuboid. When you are looking at it from the top, this is what you have. We call it plan. When you are looking at it from this angle, this is what you have. Now, when you're looking at it from this angle, this is what you have. We call these two elevation. Is that okay? We call the whole of these three engineering drawing. Now, this is the tray, just like I did before. By the time you fold this place up along this line, you fold this place up along this line, you fold along this line, you fold along this line, then you will have a solid bar. By the time you fold here again, because this side and this side must be equal, this side and this side must also be equal. So you draw a line here. By the time you fold up, it will form back your cuboid. Now, all solids have surfaces or face. Most solids also have edges. Now, like I said before, this place is called the face. This is one face here. This is one face here. As far as we are concerned, we can only see this face, and this face. Now, where these two faces meet, this is one face, and this is another face, is called edge. You can see it here. This is one edge. 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 That is where two faces meet is called edge. Now look at this angle. Where this angle, two or more angle meet, we call it vertex. You can see that. We can have more than two. Look at this place now. 1, 2, 3. We call it vertex. You can see this kind of example in any cuboid, like your ceiling. This is your wall, then this is the distance between the ceiling and the floor, like you have in your houses. Now, the net of a cuboid. The net of a cuboid. Now, look at, like I said before, when you cut along this line, cut here, cut here, cut here, you will have the net of a cuboid. This is the tray of a cuboid. By the time you open up this is what you will have. When you fold back again, you have it again. Now, we move to cube. A cube is a cuboid in which all 6 faces are square. You can see that kind of example in your dice. In dice. 1, this is 2, this is 3, just like that. You can see all the faces are square and they are equal in shape. We call it a cuboid also. Is that okay? Now, this is the net of a cube. By the time you open, you can see when you cut along this line, you open outward. You can see the flat face, the flat inside here. This is it here. You can see now. By the time you open this outward, this is this. When you open these two out, you can see it now. This side, you can see. This side, when you open it, this is it here. By the time you fold along this line again and this line, you have your cube again. The same thing you have here. You can see we folded this place 2 times, but here we have to fold how many times? 3 times, because unlike this one that has 1 here, there is no shape there. So we have to fold this place 3 times. Then we fold along this line to get our cube again. Now, make sure you get a cardboard, draw this outline, cut it out, then draw a line and fold along those lines to get a cube. And you can screenshot and send to me on my email address. Now, a cylinder. This is a cylinder. A cylinder has two faces, and each faces are circle. We call this place the top, and here to be the base. Now, the thickness, that is the distance between the upper face and the lower face, or the base, now is called H. Now, by the time you draw a circle and draw a line to join them together, you would have formed out a cylinder. Example of cylinder in our home is tin milk, or your beverages like your milk, all those stuff you use in the house, like your buckets or your drum at home you use to store water, all are in form of cylinder. Now, to get the net of a cylinder, by the time you cut along this line, you open up. These are the two circles. This is what you have. By the time you open up the body fully, you have a rectangle and two circles. Is that taken? That is how to form a cylinder. Also, get a cardboard, cut two circles out, cut a rectangle, fold along this line just as you have here, then cover it up and sellotape. By the time you are through, you would have formed out a cylinder. Now we move to prism. The base and top of a prism are always same shape. A prism is named by the shape of the base and top faces. Now, depending on where it's facing, like now, we have all this one to be base because they are downward. If they are facing up, they become top. Now, the first one we have here is a triangular. You can see the one face is what? Triangular. But the base is what we used to name them. The shape of the base will tell you the kind of triangle you have. Now, look at. This one is a triangular base prism. This is what? A square base prism. Never mind the diagram. It has been stretched. So it now looks as if it's a rectangle. It's actually a square. Now, how many shapes do we have here? This is actually a regular polygon. That's 6 sides. So it's a hexagonal base pyramid. The shape of the base will determine the name of the pyramid. Now, a pyramid has all the faces, they meet at a point. You can see, we say where two or more lines meet, we call it vertex. Now, look at, this is the vertex, vertex. Now, you can see, the number of faces determine what we have. When we have tetrahedron, it means 4 faces. Look at 1, 2, 3, 4, and the one at the back. Look at it here. This is one face. This is second face. This third face is at the back, while the face at the base is called tetrahedron. That is prism. Now, how do we get the net out? The net of a square base prism. Look at, this is a square base prism. By the time you cut along one line, you would have opened up the prism into its net. Depends. You can open up along this line or along the face. Now, look at what we have here. This is what we had before. Don't mind my diagram. By the time you fold this one in, and they meet at a point, this is what they will form out. You can see. These two, when you fold along this line, and along this line, they will also form the same shape. See, when you see the net of a shape, you should be able to tell which figure is it. By the time you see this, look at, you know it's a pyramid. By the time you see this, you know it's a cylinder. It's as simple as that. Now, we move to cone. A mold of rice or beans is often cone-shaped. Now, just like when you pour rice on the floor, on the ground, it will form like something like mountain. Now, look at what we have here. It will form the shape of a cone. It's not different from what we have here. When you use measurement to take, or like a cup, to take some grain of rice, this is what it will look like. You can see the top is like a cone. Another example is the roof of a house and the sharp end of a pencil. Now look at the sharp end. It's like a cone. Look at this rooftop. Is what? In the form of cone. Now, how do we get the net of a cone? Just like the way we cut out cylinder. When you cut out along this line, you open it up. Fold out, you have and the circle. This is called a sector. A what? A sector. Just like when you have a circle and you cut some portion out. This is called a sector. Get the cardboard, cut out like this, and fold in to form a cone. Open up again to form the net of the cone. Now, activity. Name the solid that have the net shown below. Now, look at this. Even without looking back at what is done before, you should be able to tell what kind of shape is this. This is what? No doubt this is a cone. This is what? A triangular base prism. And this is what? A square base prism. Now, this activity you are going to do, you cut out, you get a cardboard, draw this outline, what you have here on the cardboard, and use a pair of scissors or razor blade, as the case may be, to cut out along this edge. Cut out, make sure you draw it out, then you fold along this line to get the square base prism. The same thing with the cone and the same thing with the triangular base prism. Assignment. Just like what you did before, you have to draw out the outline, cut out and fold along the edge to form a pyramid. Now, how many faces can you see? How many edges can you see? How many vertices can you see? Now, here is one for you to practice. You have to measure, cut out, and fold. What is your shape? What can you say about the figure that is being formed out? Now, summary. Cuboids, cubes, cones, pyramid, cylinder, and sphere are special three-dimensional shapes called geometrical solid. 2. All geometrical solids have one or more faces, as we have seen. These faces may be flat or curved, plane. It's called plan or plane or curve. Many geometrical solids also have edges and vertices. Now, a skeletal view of a solid shows its face, edge, and vertex, just like the assignment and activity you are to do. You have to draw out the edges, then fold along the vertex, along the edges to form the vertex. Now, the net of a solid is the flat shape that can be folded to make the solid. Now, for further reading and exercise, go to your new General Mathematics JS1 from page 38 to 49. Till I come your way next week. Stay safe and God bless.